and then I sprinted back to my car.
You got it right.
Yeah. Well, like, because I had jogged the first half, and then I saw him and it scared the daylights out of me, so I sprinted back to my car, which was 2 miles away, so it was a good workout. Oh, but the moral of the story was don't go running by yourself at 5 o'clock in the morning. It's a bad decision.
Did you tell anybody, or did you just say that you?
I told my mom. I was scared.
I usually when I'm down, I'm with
Missed it.
Yeah,
Oh.
so the quiz today is going to cover the
Three.
I don't remember the numbers, I remember like the content. So it was like chain roll, I want to say it was product quotient chain, marginal cost revenue, product. I thought you said marginal cost revenue was more on the next one.
No, the rate.
The what? And the implicit. Implicit is dividing it. I was like, I got here at lunch. I was like, oh, is that late? We have a test today. It's like 12. I haven't realized it got late. Oh, no. That's when I realized I had this today. And I was like, oh, well. I'm gonna fix something. Okay.
Yeah, I figured it out. Like I was like, oh, okay, that makes more sense. I wouldn't have thought of it like just factoring out the maybe. So we won't have anything like that when we on the quiz.
Never that involved. Maybe as a bonus.
I think that's.
I don't remember, I remember it, there was no, like, all about that, yeah.
Yeah.
Denominator, numerator, numerator,
But yeah.
I assume this computer was up already. And I started code and it's getting very slow. And I reported it. My computer's not working.
They have some new screens in the business.
And next door.
Oh, and that, oh, they're nice.
This building gets inspected. I think over the summer, the business building got computers. And like most, I think, Mel Gama's class last semester got a different board. No computers. I see a couple classes do.
The display next door is great, but you know, I always have to pick at something. And when I write, it's harder glass and it taps. And so it's like tap, 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 tap. And I'm like, it's driving me insane. But you know, it's a great display. I just need to use it.
It's pretty neat. It's pretty neat. It's just like Mission Impossible 5-10 years ago. Everybody thought that was gonna.
It's
And it is.
very clear. They're probably going to hear eventually. This thing's getting very good.
When we gonna replace the computers downstairs.
Oh, are they?
No, when are they?
Oh, you mean the ones in the 201? It's used so seldom now. I don't know what they're going to do. Do you go in there just to work? Or what do you,
Those things are almost 3 years old, at least.
but I think they only have like 2 classes in it. So I don't know if they're going to. But they are.
Even the old business ones would have been better than those.
You looking for, if there are any more questions you'd like me to work out? I know some of them you might have had trouble getting the answer they had in the back. But, we can look at some of those if you need. Slowly but surely, it's loading. You're not just a machine. Any of the homework we should look at? Yes. Is that on 3-6? X squared, this is 13. It's thinking about it. There we go. X squared minus 2xy equals 6. We want to find dy dx. Did you say this derivative would be 2x? I would think of this as a product of 2x times y and use the product rule. So I'll have minus first times derivative of second plus derivative of first times second equals derivative of 6. You think that's where it might have fallen apart, that product rule apart?
Should it be instead of plus 2y negative? No?
This negative will distribute.
It will, okay, that's right.
Okay, so 2x minus 2x dy dx minus 2y equals 0. If I subtract 2x and add 2y to get them to the other side, negative 2x dy dx equals negative 2x plus 2y. And if I divide by negative 2x, I'm not sure what they prefer. If I split it into two fractions, it would be 1 minus y over x. Or they might have factored out a negative 2 and called it x minus y over x. The negative 2's would cancel. it would be x minus y over x. Either of those two ways would be fine with me. Whichever you prefer. Did they give, they did this? That's good. Okay. That's a good middle of the road one that I think, I would like you to know how to do that one. Any others? Yes.
Oh, no.
Let's see here. X plus y cubed plus x cubed plus y cubed 0. Let's see how this one goes. Are you cold? Chain rule here. 3 times the inner to the second times derivative of inner, which will be 1 plus dy dx. 3 that squared times derivative of that. Plus 3x squared. What would this one be? 0. Okay. Alrighty. The problem I see is trying to get the dy dx's alone. If I distribute this whole big thing through this parentheses, I get 3x plus y squared plus 3x plus y squared dy dx. I'm going to go ahead and I'm going to move the 3x squared away. Okay? So plus 3y squared dy dx equals negative 3x squared if I subtract it. I also should move this one over. Okay? If you let me, I'm going to erase this and just write minus so I can save some space down here. You don't mind?
So if you try to factor out the 3 dy dx.
Yes. Yes. Factor out the dy dx, and that leaves 3x plus y squared plus 3y squared. And that's what I'll have to divide by in my last step. 3x plus y squared over this. These would cancel. And then it's a matter of saying, is there anything more I could do with that? I could probably factor out a 3 and make it look a little nicer, but I don't know what the book did. Did they factor out a 3 and cancel it? Did anybody look? See, if I factor out a 3, I could do it top and bottom and it would go, so that would just be negative x squared minus the binomial squared over yeah. I was starting to think if these were the same, if those were the same, it would have been 1, a negative 1, but no, it's going to be different. So it would be. So you could factor out a 3 and cancel it, or just leave it like that. But that's about the best we could do with it, except for the 3's. Yes. Okay. Any others that you're concerned about? Okay. 7. Let's see. X over y minus x squared equals 1. If I use quotient rule carefully on that first fraction, I would have denominator times derivative of numerator minus numerator times derivative of denominator, which we would have to call 1 dy dx, right? Over denominator squared minus 2x equals 0. If I want to get rid of this fraction, I can multiply everything by y squared, and I would get this numerator, x to the power of dx, minus 2xy squared equals 0. And then I'm able to move these bookend terms to the other side and divide by negative x. So that will look like negative x dy dx equals, I'm going to call it 2xy squared minus y. And then I'm going to divide by negative x. And I get dy dx equals, to make it nicer, I guess I could split it into two fractions. Negative 2y squared over x. No, negative 2y squared, the x's would cancel. The x's would cancel. And then that would be plus y over x. And that would be a good form to have it in, I believe. They might say y over x minus 2y squared. Is that good? Is that what they gave? Or did you know?
I think so.
You don't have to look.
I got it. It's 1 minus x squared over 1 plus x squared squared.
For 7?
Uh-huh.
Yeah.
What? That doesn't make sense.
Really? Can I check on that?
No, you're,
And there's 2.
That's number 7 on 3-6.
Okay, that one, that's part B.
Yeah.
Oh, I see. Yeah, they wanted you to do it 2 different ways and to show that they were the same.
this B is the way that you have it.
B is what, yeah.
B is the way that you
What they wanted me to do was to solve it for y ahead of time and then take the derivative and then show that they were the same. And really, if it's not solved for y, I would make you do that. That's a nice exercise. If I were to like move this over and actually solve this for y, clear the fraction, try to get the y line, I won't make you do that. As long as you understand how to find the implicit, that's okay. They just wanted you to do it the old way.
Oh, yeah.
All right. Any other concerns? Like I told you, I was concerned about us getting behind. So I am going to, and I usually will take this problem, don't expect it all the time, but I'm going to let you take this quiz home as a take-home one, since I don't want to use class time for it. So it'll be due on Wednesday. And we're going to go ahead with our notes so we're not even more behind, if that's okay.
Okay.
We're skipping over to 4.1 now. And I think you're going to find these to be not too bad, but there are a lot of definitions and procedures. Page 258. 258. Says this. Okay. We need to define, if it'll come up, increasing and decreasing intervals. Come on up. I touched it. There it comes. There we go. This should make perfect sense even though it sounds very mathematical. A function f is increasing on interval I if y2 is greater than y1 whenever x2 is greater than x1 for any x1, x2. This is basically what it means. As x increases, y increases. That's an increasing interval. So if I gave you something like this, they're going to start saying For what x values is it increasing and when is it decreasing? You'd say, well, it's increasing maybe from negative infinity to here, right, on that x interval. Then from here to here, it's decreasing. And then from here to infinity, it's increasing. That's all we're saying. Same thing for decreasing. The function's decreasing if y2 is less than y1, whenever x2 is greater than x1. In other words, as the x increases, the y's are falling, right? Decreasing. From here to here, it's falling on x. That interval of x's, it's falling. The y's are decreasing as x increases. So how could we do that? How could we do that with what we've learned about derivatives? You know that the derivative of any point in this interval is going to be positive. If I take the derivative anywhere here and take the slope of the tangent, it's negative. Negative slope, right? Increasing. That's what this is saying. Let f be differentiable on open interval I. F is increasing on that interval if the derivative f prime of x is positive, greater than 0 for every x in I. And the function is decreasing on interval I if the derivative is negative for every x in I. So that's all we have to know. If I test some x value and the derivative is positive, I know it's increasing. If it's decreasing, if the derivative is negative, it's going to fall. It's going to be decreasing. And this is what helps us to make it easier to find those intervals. When f of x is a continuous function, no breaks or gaps, f of x can change from increasing to decreasing or vice versa, only where the derivative is 0. And that makes sense, doesn't it? If it's increasing, then the slope's 0, then it changes, doesn't it? Then the slope's 0 here, and then it starts increasing. So it's going to change when that derivative is 0, and you have a horizontal slope. That's what we're going to do. So here's your procedure. That's the first questions they ask you. How find the intervals where f is increasing or decreasing. What intervals of x values? Well, first thing I'll do is find the zeros of the derivative and any numbers for which f prime is undefined. Okay. Let those numbers from step 1 be dividing points of intervals of x values. Intervals of x values. And then test an arbitrary x value from each interval to see if it's positive or negative, if it's increasing or decreasing. That sounds pretty easy, doesn't it? Want to try that? I picked out some on page 258. Quick one to start with is number 16. See if we can do that. 16 says f of x is 2x squared plus x plus 1. Well, the first step said find the derivative and set it to 0. What's the derivative of that? That's easy. 11. So set that to 0. What is x going to be if I solve for it? Okay. So my second step is to let this number or numbers be the dividing point of my x-axis in the intervals. So since I only have one 0 of my derivative, I'll let that be my one dividing point. So if I split the x-axis into two intervals with that as the division, the first interval would be this, wouldn't it? And what would the other one be? All we did is we took that number and we split the x-axis into two intervals, from negative infinity up to negative 4, and then negative 4 to infinity. Okay. Good. And then what I want to do is I want to test an x value from each interval to see if it's the derivative is positive or negative. So tell me, what's a nice round number inside here that I could test? That sounds good. If you put negative 2 in for x in your derivative, what do you get? You get negative 7? Negative 8 plus 1? Well, since that's a negative number, I guess this interval is what? Decreasing. This interval is decreasing. Testing, my favorite number for this interval would be 0. Would 0 in here? F prime of 0 gives me what? 1, which is positive. So that means this interval is increasing. Well, we've just answered our question. This function decreases from negative infinity to negative 1/4 and increases negative 1/4 to infinity. Well, how could you verify that? Graph it. If I graph, once it come up, if I graph 2x squared plus x plus 1, I'll wait for it. Come on. It's thinking about it. There we go. Y equals 2x squared. Oh. It's not being very nice to me today. I wonder if it would like it better if I did that.
Mine better.
Y equals if you graph it just on a standard window, can you see it?
Yeah.
2x squared. Is it plus x? Plus 1. Just on C6. You see, from negative infinity to negative 1/4, it's falling, and from negative 1/4 to infinity, it's increasing. It's all they want you to see. And that's just a good basic example of it. So we gave the intervals of x values where it's decreasing or it's increasing. So that's what we're doing. That's this whole section. Of course, they're going to get a little tougher than that, right? Let's skip to 22. See if we can do that one. Can you find the intervals of increasing and decreasing for that? 22. F of x is 2/3 x cubed minus 2x squared minus 6x minus 2. Help me find f prime. All right, if I bring that 3 in front, the 3's cancel, and I get 2x squared minus, you said, 4x minus 6. If I set that derivative to 0, can you factor 2 out? X squared minus 2x minus 3. If I factor that in, I think that sounds good. Has to be 3 and 1 minus plus, would you agree? So what are my two zeros if I set those to 0? 3 and negative 1. Tell me my intervals this time. From negative infinity up to what? To negative 1, that's the first one we come to. And then, if these both numbers split the x-axis into intervals, I go from negative 1 to that 3, don't I? And then what's my last interval? 3 to infinity. So those two numbers, if you just think of your x-axis, if you put a dot at negative 1 and a dot at 3, that separates your x-axis into those three intervals. Okay. Now let's test a number. Give me a good test number from the first interval. What's inside there? -2. If I put -2 in there, that's going to be 8 plus 8 minus 6. Is it 10? Is that right? You agree with that? Positive. So since that's positive, what's this interval doing? Increasing. My favorite number in the second interval is what? 0. I like that. That's -6, isn't it? If I put 0 in for x. So what's this interval doing? Decreasing. Right? And I guess we can try 4 from the last interval. 4 would be is it 10 again? +10. So this interval would be increasing. So there are my answers. It should be increasing and decreasing and increasing. If you're not satisfied with your answers, you graph this original and you see. Okay? See how it looks. Make sure that that's what happens at those points.
Wouldn't that -2 answer be correct?
It's actually negative.
Oh, is it?
-2 squared is 4 times 2 is
8 plus 8?
8. Maybe it's 9.
Should be
Is that like
-6.
8 plus 8?
It's not -2.
16 minus 6? 10?
I've got -6.
Might just be close.
Did you, let me see how you did it.
I just put the derivative and then that's
Ten,
the
yeah.
ordinate. Oh, it's -2. I'm sorry. Duh. It is 10.
I always ask though, because
I'm sorry.
you know how easily I can make it good? When you graph it though, you should see this happening. Up to -1, it's increasing. Then between these two numbers, it's falling. From 3 on, it's increasing. Easy to verify. Okay. How about 26? Says h of x is 1 over 2x plus 3. What am I going to have to use for this? We could do chain. It might be just as easy to do quotient. If we say h prime of x. If we think quotient, the denominator, if I can write, let's see, denominator times derivative of numerator minus numerator, denominator, 2x plus 3 squared, 2 over 2x plus 3 squared. Okay? Now remember my original statements. We want to see where these are 0, where the derivative is 0, or where the derivative is undefined, right? So, are there any zeros to this? There's no, the numerator can't be 0, so there are no zeros. So we would have to say, there are no zeros, but f prime of x is undefined, please. What number could I put there to make a 0 inside there? -3 halves. If you set that to 0, if I put -3 halves in for x, I get 0 in the denominator. So that's my only place it might happen. So I would split my x-axis from -infinity to -3 halves, and then -3 halves to infinity and see what happens. -3 halves to infinity. That's my second step, and my third is to do my test numbers. That's -2 again, that's been a good standby. if I put negative 2 in here, when I square whatever it is, that's going to be a negative fraction, isn't it? It would be negative 2 over 1. So it's decreasing on this interval. And what about if I try 0 inside this interval? The negative 2, what's it still doing? It's still decreasing. So it never changes, does it? It's decreasing for both those intervals. But I can't have x to the negative 3 halves. If you graph that one, you know it's a rational function. 1 over 2x plus 3. 1 divided by parentheses 2x plus 3. Wow. Come on. Plus 3 close. If I stay on a standard window, you see the two pieces? So do you see that from negative infinity to negative 3 halves, it's decreasing. And then from negative 3 halves on, it's still decreasing. So it's always decreasing on both those intervals. And that's what we would say. So that was a good example where there were no zeros with the derivative, but we said there was one value where it was undefined. The derivative was undefined when x was negative 3 halves, and that split my x-axis into two. Go ahead and turn over to 260. Here's how we're going to use this. A few more definitions. Okay. Let's see what this says. This is just what we saw, right? If f prime of x or f of x is undefined with a certain x value, the function could change from increasing to decreasing, but doesn't have to. You saw this one, it didn't, did it? It was decreasing, and then it was still decreasing. Okay. Here's what we want to say now. Let me move this up for these two. The number m, capital M, equals f of c is a relative maximum if f of c is greater than or equal to f of x for every x near c. We would call this a relative maximum value for that function. You see how it's the highest y value in the vicinity of that x value? That x. That's a relative maximum. The number little m equals f of d is a relative minimum if f of d is less than or equal to all the f of x's for every x. So for this x value, this would be considered a relative minimum. That would be. Because within this region, that's the lowest point. It's not the absolute. In the next section, we talk about absolute maximum. Do you see that if this goes on forever upward, there is no absolute maximum? There's no maximum value because it increases forever. But within these little regions, there is a relative minimum and a relative max. And that's usually what we like. Okay? How do we do that? Here's how. Also, if they ever call the relative max and relative mins extreme values or relative extrema, that's another term for it. Okay? Just means relative max or relative min. Okay. Here's a theorem. Let f be a continuous function. If f of c is a relative max or min, then the derivative is 0 or f prime of c fails to exist. Okay. So if it's a max or a min, then the derivative has to be 0, like we were saying, or the derivative fails to exist. Okay. And we're going to call those numbers where that happens critical numbers. Numbers for which f of x exists, so the original function exists for this x value, and either f prime is 0 or f prime fails to exist. Okay? So it's not a critical number if the x value makes f of x undefined, but it could be if f prime fails to exist. But we're basically looking for all the zeros of the derivative. We'll call those critical numbers. Okay? The derivative 0 or fails to exist. And we found those in the last few problems. We set the derivative to 0 and we found those critical numbers, didn't we? Right? Okay. And here's what's called the first derivative test for relative extremity. Okay? Let C be a critical number for function f on interval I. Alright? This is going to make perfect sense. Think about this. If f is increasing for x less than c and decreasing for x greater than c, what have you got? You've got a max. If it's increasing and decreasing, you've got a max value, don't you? Okay. If f is decreasing for x less than c and then increasing for x greater than c, what have you got? You've got a minimum, don't you? You've got that low point. If it's decreasing, then increasing. If f of x does not change sign at f of c, then f of c is neither a max nor a minimum. When might that happen? You can see that this is a max. It's increasing and decreasing. Right? This is decreasing and increasing. That's a minimum. But what if you had something like x to the third? That's our increase. If you had something like x to the third, it's increasing, but then it keeps increasing. It didn't change, did it? So that's neither a max nor a minimum. Sometimes that's called a saddle point. But sometimes that'll happen. But that is called the first derivative test. But don't think about the words, just think about increasing and decreasing, max, decreasing and increasing, minimum. Or negative. And here's how you put it all together. To find the relative max or min values for a function, step 1 we know how to do. Find f prime. Step 2, we did it just a second ago. Find all critical numbers by doing what? Setting f prime to 0 and solve. Did that just a minute ago. Then I'm going to do like we did before, test a number from each interval created by the critical numbers to see if it's positive or negative, increasing or decreasing, and then apply that rule. If you go from one interval to the next interval, if it increases then decreases, what do you have? If it decreases then increases. That's not going to be hard, is it? That was a lot of words, a lot of lead up to this, but that's a simple procedure, don't you think? 4 steps. Want to try it? Okay. You knew I was going to do it, whether you said yes or no. 52. 52. Find the relative max and min of each function. 52 says f of x is 1/2 x squared minus 2x plus 30. What was step 1? Find the derivative. Easy. What is that? Bring the 2 in front, they cancel, and you get x to the first minus 2, right? Step 2 said find the critical numbers. Well, what's the only critical number? Okay. Step 3 says, just like in those early problems today, set up your intervals that separates your x-axis into. So we say what? What's my other? Okay. Now let's test a number from each interval and apply our first derivative test. What's going to be my favorite number in this interval? Yes. If I put 0 into f prime, what do I get? So this is decreasing. If I put 3 from this interval inside my derivative, what do I get? Positive 1. So this is increasing. If it's decreasing and increasing, what happens at 2? If it's decreasing and increasing, it's a minimum. You're right. So let's say that. Our conclusion is relative minimum at 2, where it's split, right? It falls to 2, then it starts rising. At 2 what? I have to put it back in my original function. Put this 2 back here. Well, that's going to be half of 4 is 2 minus 4 plus 4. What's that? Relative minimum at 2, 2. You think we got it? You want to check it real quick? If I graph 1/2, call that out to me. 1/2 x squared
Minus 2x plus 4.
minus 2x plus 4 on a standard window. Where's the vertex? That's 2, 2, isn't it? What's it doing to 2? Decreasing. What's it doing from 2 on? That's it, isn't it? At x equal 2, there is a relative minimum at 2, 2. Isn't that great? That's not hard. Could they be hard? No, they could be hard. Right. But we're going to practice enough to where you can say, oh, these are easy. 56, better one. Cubic function. 56 says f of x is x cubed minus 3x plus 6. What is your derivative? 3x squared minus 3. What do I do to find my critical numbers? Good. Can you all factor that? What comes out first? 3 leaves what? How does that factor? Yes, difference of squares. What are my 2 critical numbers then? If I set those to 0? Yes. For my third step, what are my intervals this time? I've got 2 critical numbers. So my first interval is -1 to 1, and then 1 to positive infinity. All right. You think -2 is a good test number? Into my derivative? 9. So this is increasing from up to -1. What's my favorite number between those two? 0 gives me -3. So this is doing what? Decreasing. And then I guess 2 is a good test number inside that interval. Are we back to 9 again? So it is increasing again. Okay, let's interpret that by the first derivative test. At this division point -1, since it's increasing and decreasing, what do I have? It's a max, isn't it? So we'll say at -1, comma, whatever I get from here. If I put -1 in there, I get -1 plus 3 plus 6. So at -1, 8, what do I have? Relative max. The other division is +1. At +1, what if I put +1 inside my original? Is it 1 minus 3, -2 plus 6? Is it 4? Since it is decreasing and increasing, relative minimum, and error mark, relative extreme values. What if you're not convinced? What do you do real quick? Graph x cubed minus 3x plus 6. X cubed minus 3x. Was it plus or minus 6? Oh, plus 6. Plus 6. Standard window again. Does that look like negative 1/8? Does that look like 1/4? I believe so. You like that? Isn't that easy? Do you remember how much trouble we would go through in college algebra to find a vertex, that formula? Remember the formula you would use? Negative b over 2a if it's quadratic? This isn't even a quadratic. I can still find the hindmost, can't I? Very cool. Very good. Okay. And it's not that difficult, is it, if you know how to find the derivative? Right? All right. Could you do it for 60? See, we keep it a little tougher. Huh? A fifth degree. Wow. How many divisions is this going to have? Let's see. Number 60. F of t is 3t to the 5th minus 20t cubed plus 20. And you know that they had to work hard to make up some of these polynomials that aren't going to be totally ugly, right? If they just gave you anything off the top of their head, we'd be in trouble, wouldn't we? So first, how do you think F prime is? I can factor out 15 what? Leaving what? Love it. You see how hard they do it to make that pretty, right? How often does that happen? No. So, if I set 15t squared to 0, that means t equals 0, right? If I set that to 0. The other two, I guess I would factor in the t plus 4, t plus 2. Yes. Yes, talking too fast, right? Plus 2t minus 2. If I set those to 0, okay, so that's good. 2, 3. Now, what's my first interval if I go from smallest to largest? Good. Yes. 0 to 2. Yes. That had 3 division points and it created 4 intervals. Okay. Let's see. F prime of negative 3. Good. Well, you know, 3 to the 4th is 81, right? 81 times 15. Just you want to do it.
675.
Is that the whole thing or just the first?
Oh, it's the whole thing.
Okay.
I
So,
wanted to do it after.
Okay.
The last simple one.
okay.
Maybe I didn't negative 1 for the second one,
F prime of negative 1.
and that's negative 45.
That was we could do in our head, couldn't we? 15 minus 60 is negative 45. Okay. And did you put positive 1 in?
Yes.
Is that still
Negative 45.
fine?
And then the positive 30 is positive 675.
675. Okay. So if it's increasing then decreasing, This is increasing, then it's decreasing. But this one's still doing what? That's still decreasing, but then it changes to what? Now let's think about this. If it's increasing and decreasing, what happens at -2? Actually, I'm going to put it as the order 3. At -2, comma, ooh. If you still got your calculator, have you entered that original function? Go to that table and plug in -2. Oh, wow. At -284, if it's increasing and decreasing, that is a what? Relative max? Increasing and decreasing? Well, if it's decreasing, then it keeps decreasing. This is neither, right? Nothing happens at 0. Right? It doesn't change, so that's a saddle point. And then at 2, comma, would it still be? No, it wouldn't be. Okay, and it was decreasing and increasing, so that's going to be a relative mean. So at 0, 0, it keeps decreasing. So if you wanted to see that real quick, have you tried to graph it? 3t to the 5th, 3t to the 5th, and then it was what? To the 3rd, and then what was the constant? Plus 20. Okay. Now you saw from what we found, I'm going to have to go up to about 100 and down to -50 to see this, right? On my y. So if I set my window, if I go from -50 up to +100, I should be able to see it. Look at that. There's my max up at 84. Then when x is 0, it doesn't change, does it? It decreases and it keeps decreasing. And then it minimums out at, what was it? 2 -44. Isn't that great? We knew that, didn't we? We verified it. We're happy with that. We like that. Right? Very good. Would 66 throw you a curveball? How do you think I would write 66 before I do anything to it? I would write 2x. All right. X to the -1 plus 2. Good. How about g prime of x? 4x minus 4,000. And that's it. And still we're working hard to make this interesting and not ugly. I set that to 0. That means 4x equals 4,000 x to the -2 if I move it over. But what is x to the -2? What can I do? Okay. Would you agree that if I multiply both sides by x squared and clear the fraction, 4x cubed is 4,000? So what is x cubed? Cube root on both sides, x is 10, and that would be my only critical number. That's the only 0 that root, right? Actually, we might have to add in, is there a number? No, think about this.
wasn't this 4,000 over x? So f of x is undefined at 0, but we said f of x has to be defined at 0 for it to be a critical number, right? If f of x is defined at that number, but f prime is 0 or undefined. So I don't think 0 is going to play into our, okay? So I think 10 is our only critical number. We will have to think at 0 it will break though, because that is undefined here. So why don't we say this? Why don't we say, just for interest, what if we said negative infinity to 0, 0 to 10, and then what? 10 to infinity? I don't think anything's going to happen here because it's undefined now. But we'll test it, won't we? We'll see. So if we say, if I said g prime of negative 1, that's going to be definitely 2 minus 4,000 plus, and that's definitely negative. I don't care what the number is. It's negative, right? So that's decreasing. If I put in 1, 2 plus, oh, so that's, oh, wait, I was looking at the wrong function, wasn't I? If we put negative 1 in here, negative 4 minus, and then we square that, it will be negative, it's decreasing. But if I put 1 in here, is it still decreasing? It's still negative. 4 minus 4,000 is still negative, isn't it? We're putting this in the G prime, remember? All right? So that would be negative, that would be 4 minus 4,000, wouldn't it? Negative. So it's still decreasing. So we were right, okay? And if I put in G prime of 11, help me out with that. Positive 10.9, okay, approximately. So that's positive, so it's increasing. So the only place I have a change is decreasing and then increasing at 10. So at 10 comma, whatever we get when we plug 10 in my original, that's not too bad, is it? 200 plus 400 plus 10. 610? That's 10, 610. We have a relative what? Relative n. And that's all that happens. It's decreasing forever, and then it starts to increase at that point, and that would be relative n. And that's way up, isn't it? Wow. To see that, we would have to really set that while window really high. See that minimum, like up to 1,000 maybe. Still an interesting one. Like I said, how often they had to work hard to set this up to where you could take the cube root at 10. That's just not expected, is it? Because it's from at 10 it's decreasing and then increasing, decreasing and then increasing, so it's a low point. Very good. Okay. The rest of these are just some application problems. Let's see if we can get through a few of those before we finish up today. Look at 72. 72 says this thermometer company has a profit function. All right? Sale of X thermometers. Profit function is negative 0.001 x squared plus 8x minus 5. Find the intervals where the profit is increasing and where it's decreasing. That, sure, copy of that. That was our first type problem, wasn't it? Didn't we just say what is P prime of X? What is P prime? That's much better than the original function, right? I set that to 0 to find my critical numbers. Divide by negative 0.02. And you say that that's going to be 4,000. What are my two intervals doing? For a real problem, what should I probably say instead of negative infinity? Could I have negative thermometers? 0 thermometers up to 4,000? You could put negative infinity, but we could have like negative thermometers, could we? Just for real problems. And we probably could have infinite number of thermometers, but we can't say for sure, so you wouldn't make an infinite number. But they didn't tell us how to do it. You could, but we probably wouldn't need it.
Put it in the supply and demand.
So if we said p prime of 1, that would be in this interval. P prime of 1, positive or negative, I don't need another number. Would that be positive 7.998, something like that? So I'll just put that, increasing. And then P prime of 4001, would that be slightly negative? If we plugged in 4,000, we get 0, don't we? If we plug in 4001, this is going to be larger than 8, isn't it? So is it going to be negative? Decreasing? If it's increasing, then decreasing. Max. So we say what? We say, well, that's all they wanted. The profit's increasing up to 4,000 thermometers and decreasing for over 4,000. That's all they asked for. They didn't say what was the max profit. So we like that. 76, not a variable. 76 says, environmental quality. The index for this environmental quality is approximated by the function that I of t equals 1/3 t cubed minus 5 halves t squared plus 80. And they say that this function is only good for years between 2000 and 2010 or 0 to 10, right? That's what they tell me the interval is for use. Equals 0 corresponds to 2000. Find the intervals for the functions increasing and where it's decreasing. Same question. Tell me I prime of t. Once again, they were very nice to you. What's that? Like it. Good. What if you set it to 0? Can you factor that? So we've got that GCF. Set it to 0, so t is 0, t is 5. Okay. Well, since this is the end of my interval, I don't need to go below 0, do I? So really, I have what? I have 0 to 5, 5 to 10. Okay. All right. So I prime of 1, positive or negative? 1 minus 5, negative 4, so that's negative, isn't it? So it's decreasing. I prime of 6. Positive. 36 minus 36, positive 6. Increasing. And that's all they asked me for. So from 0 to 5, that index was increasing, and then decreasing, and then it's increasing from 5 to 10. Year 5 to 10. So 2005 is where it changed from falling to rising. All right. Are you feeling pretty comfortable with most of this? If we can do one more, I think I'm satisfied on getting your quiz. 84. We write the drug concentration in the blood column. So, 84 says, concentration of a certain drug in a patient's body T hours after injection is given by C of T. It's T squared over 2T cubed plus 1. This interval is what? 0 to 4, and that is hours after injection. When is it increasing? When is it decreasing? Same old question. Like a broken record. What do I have to use, unfortunately? Denominator times derivative of numerator minus numerator times what? Derivative of denominator over denominator squared. Not pretty, but maybe not as bad as we think. 4t to the 4th plus 2t minus 6t to the 4th. 2t cubed plus 1 squared. That simplifies to what? 2t to the 4th plus 2t over 2t cubed plus 1 squared. If I have to set this to 0, what's the only thing I'm worried about? The only thing that makes this fraction 0 is if the numerator equals 0. So I don't even have to think about the denominator except where it might be undefined. And for 0 to 4, would this ever be 0? It would never be 0, would it? So I don't care. All I care about is when that numerator is 0. So I'm going to come over here and say negative 2t to the 4th plus 2t equals 0. What can I factor out? Negative 2t looks good. T cubed minus 1. Okay? Either negative 2t is 0, which means t is 0, or, do you remember how to factor that from intermediate algebra? It was a formula, wasn't it? Difference of q's, t minus 1, t squared plus t plus 1. You remember that formula? No? I'm not. If you set this to 0, what's my other critical number? This has no real zeros. You would have to use quadratic formula, and that's not going to give you anything but imaginary stuff. But this is the only real thing. Whoa! Ouch. So, what intervals would I set up? 0 to 1 and 1 to 4, because that's my whole interval here. Okay. Oh no. Guess what we have to test? C prime of 1/2, and then C prime of 2, something like that. Oh, I don't like it. I wonder if we could predict what sign it would be. Ah, we can. Look, if I put 1/2 in here, right? That's going to be negative 2 times 1/16, so that's negative 1/8, plus 1, 7/8 over a positive number, because I'm squaring it. Positive. Done. Increasing. If I put 2 in here, that's going to be negative over positive, isn't it? You agree with that? I don't care what the number is. I care what the sign is. This would be a negative number if I put 2 into this derivative, into the simplest form of it. So that's decreasing. And wouldn't you expect that for the first hour, it's increasing your blood, then it starts to dissipate. This is what they wanted. The ones I want you to try are just these. From page 259, 13 through 41, odd. 49 through 83, odd. And that's it. Practice on those. Here's your quiz. Due on Wednesday.
Could have been.
The last part was a little bit of a strange word. Stuff to tweak my brain.
I was like scared of something worse than what we did last week.
We only have one more section before our next test. What I'm thinking is Wednesday we'll finish most of it. Monday review and last take